Hello guys, welcome back to Coding. So guys, I hope you all are doing great and enjoying the videos that I'm posting for you and loving the content and also understanding each and every concept clearly. So right now what we are discussing the operating system playlist, and the previously video what we had discussed, we had discussed about different system call and the system component. In today's video what we are going to discuss, we are going to discuss about what do we mean by process management, what are different types of process that are involved in process management, what are different types of scheduler that are present, and what do we mean by a process control block. After doing all of this, what are we going to learn in the next lesson? We are going to learn about the operation. So guys, if you are new to my channel, please do like it, share, subscribe to my channel. Already on my YouTube channel I have posted content that is really useful for you: networking, Python, C, Java and SQL and everything, HTML, CSS, all the videos that you will get, even Excel shorts and also Python shorts. So do check that out, and also please do subscribe and also ask your friends as well. So let's get started with the video without wasting any time and understand each and every concept clearly, concisely, and dive into the operating system. So the very first thing that we have is the process management. Now what do you mean by process management? So basically a process is a sequential program in execution. Like it will have a sequence of things, it will work in that accordingly. It is a dynamic entity whereas program is a set of instructions written in any programming language to do a specific task. So basically a program is a static entry. Means everything that we have divided in a program, it will work according to that and will be based upon that set of instructions. Now whenever we are talking about process management, it involves some states into it. So basically process state, that is the current position of a process, is known as the process state. It is defined as the current activity of the process. Now whenever I'm talking about the process state, basically it will tell us that in which category right now the process that I'm working on is present. So basically it has 5 categories: new, ready, running, waiting and terminating, or also we can call the terminating as exit. So these are the 5 stages of a process state. To each and every type of these state one by one. Now coming to the very first state that we have is the new. So basically what is the new mean? Process that has just been created. Means whatever process that has been just created now, that is called as a new stage process. Second, ready. Ready process are waiting to have process or allocated to them by operating system so that they can run. Now what do we mean by ready? Like as we are about to run, we have a race or something. So they ask us to do 3, 2, 1, ready, go. And so what is ready? Basically a process that is waiting to have a process or allocated sub process and is ready to run. Third, running. The process that is currently being executed. A running process possesses all the resources needed for its execution, including the processing. Basically, what does it mean? Like whatever process that I want to do, it is in a running state and all the processes are being needed to execute. That is called the running state. Fourth, waiting. Process that cannot execute until some events occur. That is called as a waiting. Running process may be suspended and sent to the waiting state. Now as we talked about earlier that what is a running process, so similarly what it can happen, it can be sent it to the waiting state. Next we have terminated. A process that has been released from the pool of executing processes by the operating system, that is called as a terminating process. Like all of the process has been done and it has been removed from the operating system, that is called as the terminated process. As you can see on the screen also, you have a new process, then it goes to a ready state, then it is running, and then it goes to exit state. Now the ready and running can be again and again moved with a scheduled dispatcher. Input out event will take place and input output even waiting event will take place. So this is all will be working. So here also we have one thing, that is called a deadlock. We will be understanding about deadlock in the upcoming videos. As we talked about the process, so basically the process has 2 states. One is the running and another is the non-running. Now when I'm talking about running, when new process is created by the operating system, it enters not running stage. Now whenever the new process will be created, so just the process is created, we have not yet running, so that will be taken to the not running stage. Process that are not running and kept in queue, waiting there to execute. When the process interrupted, that process is transferred into the waiting queue. If the process has completed or aborted, the process has completed, it is discarded. In either case, the dispatcher then selects a process from a queue to execute. So now to make this understand very clearly, as you can see in the diagram, first of all I have enter, then it moves into the not running case. Then we have a dispatch, it moves it to running, and also we have a arrow that shows us that it will pause it and then it will exit the queue. So basically the queue is something like that, as you can see in the block, that is a pause queue. Then it will give the processor, then it will keep on queuing the process until if it wants to exit or it wants to perform that thing. So is these all things that is called the state transition diagram, as you can see on the screen. Next thing that we have is the schedulers. Now when I'm talking about the scheduler, these are also called as dispatchers. So basically these are of three types. Number one is long term. So basically they are also called as job schedulers. They select the process from the queue and load them into the memory for the execution. So what they do, they select the process and then load them into the memory for execution. When the process changes the state from new to ready, there is a long-term scheduler. It also controls the degree of multi-programming. Second, we have short-term. These are also called as CPU schedulers. If there is a change of process from ready state of the process, then short-term schedulers also work. These are also called dispatchers. So basically the short-term, they select from among the processors that are ready to execute and control the CPU to one of them, the desired part. So that is called as the second type, that is the short term. Third, we have the medium term. It is a part of swapping function. It removes the process from the memory. It reduces the degree of multiprogramming. They also in charge of handling the swapped out processes. So basically we have three types. First one, long, that are called as job scheduler. Short term, that are called as CPU scheduler. Medium term, which is used for swapping out the processes. Talk about the next thing that is really very important in part of the video. That is the PCB. That is Process Control Block. So whenever process changes state, the operating system reacts by placing the processes in PCB. In the list that correspond to its niche stage, each process contains process control block. Now whichever process we are talking about, it will always contain a process control block. Now what will a process control block contain? Pointer, process state, process number, program counter, CPU register, memory allocation, event information, list of open file. Now what do we mean by the very first thing, that is pointer? Pointer used for maintaining the scheduling list. Now it will maintain what it will be the scheduling list. For that we use a pointer. Second, we have process state. State program is running. In which state does the program is currently running, that is called as the process state. Third, program counter indicates the address of next instruction to be executed for the program. Basically program counter means it will increment it to the next value, so where the program need to store it or where the process needs to work. Next, we have the event information. For the process in the block state, the field contains the information concerning the event for which the process has been waiting. That is called as the event information. Then we have CPU register. Depends upon the computer architecture, number of registers and the type of register that we are using in the operating system. Next, we have memory management. The information may include the value of base and limit register. The information useful for real continuous memory whenever the process terminates. 7. Accounting information. Real-time use, date time, limit jobs or process numbers and account numbers. Everything are coding under process accounting information. PCB also include the CPU scheduling, input-output resource management, file management information and the priority. So basically what is a process control block in a whole? Basically everything that a process has, any processes that what it is in a running state or not in a running state, what are the input output thing, what are the CPU thing, everything will be stored in the process control block, as you could see in the diagram. I hope you must be clear about the different types of processes that we have, what is we mean by process management, and what are the process control blocks and the algorithms and the type of process state. So guys, if you like it, please do like, share and subscribe to my channel. Already on my YouTube channel, everything is there. Please do check it out and also share it as much as your friend. In the upcoming video, we will talking about operational processes, like how each and every process work, create or delete or everything what we can do on a process. So guys, if you like it, please do like, share and subscribe. Thank you so much for watching. Keep smiling, take care and have a